Alrighty, welcome to Chapter 7, Section 1, Multiplication Properties of Exponents. So this is for Integrated Math 1, or IM1. A couple things that you'll see on the front screen here. So you should see a due date on your screen. You won't see it on mine because this is a teacher preview, but definitely should be there on yours. The attempts is the second piece here. You always have unlimited attempts, meaning that you can go through this assignment as many times as you would like. Number of questions on this particular assignment is 9. Just depends on the section for how many questions we have. Grading policy, always best score, so whichever attempt is the best one is one you keep. And partial credits enabled. So if you answer 1 of 9 questions, you get credit for the 1 question. Down here it says once you start your homework, you must finish it before you can work on anything else. So that means once I click start here, down in the bottom right corner, you will see the words submit assignment. At this point, no matter what, even if you don't start anything or if you only do a couple of these, you need to click submit assignment. Number 1, stops the system from locking you out of all of your other assignments, just like that other screen said. Number 2, it actually affects the grade book so that we as teachers can see what you've been working on, and it will, increase that score. If it's a 0, it'll at least bring it up a little bit if you've worked on something. If you haven't worked on anything, it'll still be a 0, and you can go back in and keep working on that. So on the side here, we have 3 tools. We have explanation. This says you're going to lose your question attempt because it's going to give you the solution to this question. It's not going to give you the answer and then let you come and type it in. Sorry, that's not how this works. You'll have to come in on another attempt to get points for this question. Example will give you an example of exactly what it is we're going to do right here. So you can read through. There's a couple methods to do this one. So I'm going to show you both methods. You can click on this again for another example if you want, or you can message your teacher directly from the screen. And when you reach out for help this way, we know exactly where to come help you because it attaches a picture of the problem. All right, let's go ahead and get started here. So properties of exponents. The first thing that we need to remember about an exponent is that it's repeated multiplication. So I have a lot of students make the mistake. They go 7 to the 4th power means 7 times 4. And that's not what it means. So we want to remember this is an exponent, and this is called a base. A base. And the whole thing together is called a power. If I have a base with an exponent, then it's called a power. So these are just, some terminology that goes with this. I think we've reviewed this maybe at the beginning of the semester, so just kind of a quick review there of what the terms are called. So remember that exponents are repeated multiplication. So if we take a step back and we remember in, grammar school or elementary school, whatever you call it, we learned repeated addition was multiplication. So for example, if I wanted to go 2 plus 2 plus 2 plus 2 plus 2, I get 2, 4, 6, 8, 10. I can count by 2s, do that too, but 2 plus 2 plus 2 plus 2 plus 2 is 10. Well, is there an easier way to write that? Of course there is. 2 times 5. There's 5 2's, and I'm just multiplying them together. It's addition, so it's not an exponent in this case. This is just multiplication, but it gives me the same answer. So multiplication is a way to write repeated addition. Well, in that same way, exponents are a way to write repeated multiplication. So instead of saying 7 times 7 times 7 times 7, I can say, well, how many 7s am I multiplying? I'm multiplying 4 of them, and my base, what I'm multiplying, is 7. So that's exactly what this means. So just be careful, make sure you understand what exponents are and what they represent. So when we're looking at it this way, and I have 7 to the 4th times, and I'm going to color code my stuff here because I like my color coding. So I have 7 to the 4th times 7 to the 4th. Well, I have 7, 7, 7, 7, and then times, that's this kind of times coming down here, 7, 7, 7, 7. So what's the difference between these multiplication and these multiplication? And the answer is nothing. There's no difference between them. They were just separated here. So if I can write these 4 7s as 7 to the 4th power and these 4 7s to 7 to the 4th power, can't I look at the entire bunch together and say, well, how many 7s do I have total? And I could say, oh, well, I have 8 of them. So I have 8 of them. My base is 7. And there we go, 7 to the 8th power. So this is the kind of expanded version. So I actually get to see all the factors here. What I can also do, if I have the same base, I can just add the exponents. 4 plus 4 is 8. That's my new exponent, and I keep the same base. So in order to do that, you need to have the exact same base. So it can't be different numbers here, like 7 and 7 work. I know the example that we did in class were 4s when we did that. It was actually 4 down here instead of in the exponents. So just make sure they're the same base when you're doing that. So I need to click this little button here and go 7 to the 8th power and check. So again, multiplication, when I'm multiplying, I'm going to add the exponents. We want to make sure we understand multiplication, adding, they both increase, they kind of go together. When we get to the division property, that's going to be subtraction. So those both decrease. So if you can kind of keep that in mind, kind of relate those to each other, that makes it a little easier here. All right, so let's go through here. So again, I'll show you one more of these expanded ones. So we have w to the 4th, so that's 1, 2, 3, 4 times w to the 5th. I forgot to change my color. W to the 5th. 1, 2, 3, 4, 5. So I have 5 of those, and then times, and I have one more. I'll do that guy in pink, like that. So I have one of those. So again, if I can rewrite these as w to the 4th power, and these as w to the 5th power, I can simply just look at the entire bunch and say, okay, how many do I have total? I have 4 plus 5 plus 1 more, and that's 10. So I have 10 w's total that I'm multiplying together. I'm multiplying all of them. So again, I can go 4 plus 5 plus 1. Make sure you know if you don't see it, it's a 1. So I still have 1 there, so I have to add them together. So that's why we get 10. All right. So w, not a. I don't know why I wrote a. To the 10th power. All right. So now if we look at this one, so this problem changes it up for us just a little bit. We have what we call coefficients, which is the number on the front here. So we have 7v times negative 2v to the 9th. So when we do this, we want to make sure we're multiplying the coefficients, meaning the numbers. So I have to do 7 times negative 2, just like I normally would. I'm going to multiply these together, and I get negative 14. And then I can multiply the matching variables with their, so we want to make sure we match them up. And they are going to start to give us, more and more. So it's not just going to be one variable. You have to match up the variables when this happens. So we have 1v here, we have 9 here. So that's a total of 10, because 1 plus 9 is 10. So I don't have to do that expanded view each time. That's definitely going to be tedious to do that for every problem, but it is a very nice visual. So we can see that there, if we wrote this out, we could see that there'd be 10 v's on here, and I can just put them all together in an exponent. All right. So this next one, yep, definitely a little bit more involved in this next one. So I have 2v to the 9th times 6w times 4w to the 9th v to the 6th. So when I'm doing this, the coefficients, I want to do all the coefficients. So 2 times 6 times 4. So 2 times 6 is 12. 12 times 4 is 48. So I want to make sure I multiply all of them. It's not giving the calculator here, but you can use a calculator if you need to. You could also do 2 times 4 is 8. 8 times 6 is 48. So it depends kind of which one makes that a little easier. If 12 times 4 wasn't necessarily easy for you to work out there. But you could also, of course, work it out like this and just write it down. And you get 8 and you get 4. Okay? So however we want to work that out. The next part are the variables. So we have v, did a not super straight line there. So v and v. So this middle term doesn't have a v in it. So there's not going to be any addition from that one. But I have 9 plus 6, that gets me 15. And then I do have another variable here that I need to take into account. I have w and w. So this second one, or the middle term, and the last term have w's. Remember, that's a 1. 1 plus 9 is 10. So I need to total them all up like that. So 48, V, 15, W, 10. All right, let's go check. Perfect. Erase this stuff. Okay, so now this is a different power. I'm going to do a different color. I know I like the pink sometimes, but it can be a little bit bright, I think. When we're doing this one, this is called power of a power is basically what it's called. Because I have a power here and I'm raising it to a whole nother power. Okay, so the base is actually, for this 2, the base is 5 to the 8th power. So this is telling me I have 5 to the 8th power 2 times, like this. And then each one of these would have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So I'm being a little lazy. Each one of these should have an 8 on the end of it. Okay, so we can still do the same type of idea that we were doing before, where I can go 8 plus 8 is 16. If I add the 2 exponents, I get 16. But I would have to kind of take these apart and know I'm using 2 of them, or whatever the exponent is out here. So instead, if we look at this, how else can I get 16 using these 2 numbers up here? Well, if I multiply, I also get 16. So if it's a power of a power, if I have a power in parentheses raised to another power, just like this, I can multiply these 2 to get the total number that I will end up with. So this is going to be 5 to the 16th power. Because I just combine these, I multiply them together. It's going to be 8 and 8, or 8 times 2. All right. So same thing here. I have 5w squared, so it means I have 5w times 5, w to the 5th power times w to the 5th power. I was saying that backwards because I'd have 2 of them. So I can just simply multiply these together and say 5 times 2, that would get me 10. So I know it's going to be w to the 10th power. And again, we can expand that all the way out and see that. We would end up with 10 w's because I would have w to the 5th times w to the 5th. That's what the 2 means. I have 2 of these. And now I can break down just this part, the base. So each one of these would have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And each one of these would have a w on the end, right? Like that. I'm just being a little lazy by not writing them out. And each one would have a multiplication symbol between them. So this ends up looking a little sloppy when I'm being lazy about it, but we end up with 10 w's here when we expand it out. So it does start to get a little tedious with the bigger numbers, so we want to know these multiplication rules to make that a little easier to combine. All right, so now I have 6v squared. Remember, it means this whole thing is squared. It means I have 6v times 6v. That's what this means. This is the base, the whole thing. So when I see it like this, yes, I can expand it out and show myself that it's 6v times 6v, and then I can go 6 times 6 is 36. And then v times v, remember this is 1 and 1, so I'd have v squared. So I can expand it out and I can see it this way, just like I was doing on these other ones with the coefficients and the variables. But I can also kind of distribute this too and go 6 squared is 36. That's 6 times 6, right? Same thing I did here. And v squared is just v squared. So we want to make sure you apply it to both pieces though, because the entire thing is the base, not just the v that it's next to. So that's another big one. I see students make that mistake all the time. Make sure you also apply it to the coefficient that's in there. So it gets applied to everything in the parentheses. So like this one, we'll see it's negative 6y to the 4th x squared. Oop, x, and then squared on the outside. So this 2 would be distributed to everything in here. Every piece gets one because everything would be repeated. I'd literally have 2 of these if I wrote it out correctly, if I expanded it. Like that. So I have 2 of them. So I'd multiply everything together. The 6's get multiplied together because those are coefficients. The y's get multiplied together because they're matching variables. And the x's get multiplied together because, again, they're matching variables. So you can definitely expand it out to see it this way, but I can just go negative 6 squared. That's going to be positive 36. Two negatives make a positive. With this one, it's 4. It's y to the 4th squared. This is a power of a power. This is already a base and an exponent raised to another power. So I multiply 4 times 2 and I get 8. And again, I can see that here. 4 and 4. I'd add them together and I'd get 8. And then x squared is just simply x squared. Because it's a 1 here. 1 times 2 is 2. So here's my end result there. 36 y 8 x squared. Dang it, too many tools here. Okay. Cool beans. All right, let's do this last one here. So this one's a little bit bigger, just, ending off the beginning of exponents here, or rules of exponents. We've used them before, but these are definitely bigger rules when we're using all of this stuff. So this is a little bit of a culminating one because it combines. So we have power of a power right here. And then we have product of powers, meaning we're multiplying powers together. So first, let's deal with this power of power. So I have 3, and I'm going to distribute this cube to every piece here. So I have negative 2 cubed. Remember, that's negative 2 times negative 2 times negative 2. That's 3 negatives. 2 negatives make a positive, but that third negative would bring the negative back. 2 times 2 is 4, times 2 is 8. So 2 cubed is 8, but it's negative 2, so it's negative 8. Then remember, this is a power of a power, so I'm going to multiply. It would be 12, because I would end up writing this out. If I expanded this whole piece would be written 3 times. And 4 plus 4 plus 4 is 12. Z to the third power is z to the 9th power. 3 times 3 is 9. So now I can use this, and I'm going to multiply this guy up here, and this is a 2, not a z. Sorry, I crossed my z's because my students tell me all the time that my 2's and my z's look very similar, and I've gotten to the point where I don't argue about it, I just fix it. So now 8, negative 8, and there's a 1 technically here, but negative 8 times 1 is just negative 8, so this just kind of comes down. And then y's, we're going to multiply together. We have 12 and 2, so 12 plus 2 is 14. And then the last one here, which I'll do in kind of a yellow. Oh, or a light blue. I guess I picked light blue. I thought I picked yellow. 9 plus 3 is 12, so z to the 12th power. All right. So negative 8. Y, I forgot to put the y in there before I hit the exponent button. Z to the 12th. Okay. Check. Did I miss something? Uh-oh, what did I miss? Did I write something down funny? Oh, I completely skipped over a piece here, didn't I? What happened to the x? So x should have just come down because there wasn't another x to combine it with. So, oops, I did miss a piece. I just completely forgot I left the x out there. So, there we go. All right, so that was section 1. I will see you in section 2.